Hi everyone, for today's lesson you are going to learn how to add and subtract rational expressions. That just means that we're going to be adding and subtracting fractions. And we know that whenever we add or subtract fractions, we need a common denominator. So before we get started for today, I would like to practice that skill of adding and subtracting fractions, whether they have a common denominator or not. So that's what I would like you guys to please do. Please try to add and subtract these fractions without a calculator. So that's what I would like you guys to please do. Add or subtract without a calculator. The first one is 2/5 plus 1/2. The second one is 2/3 plus 1/9. And the third one is 10/11 minus 4/22. And the fourth one is 3/5 plus 2/5. So go ahead and add and subtract these different fractions. Go ahead and pause the video, and then we'll come back together to check out your answers. Okay, let's go ahead and check how well you did. So in order for you to add two fractions together, they need to have a common denominator. And so you look at the numbers that are given to you. And 5 and 2, they don't have anything in common. So the greatest common denominator between 5 and 2 is their product. 5 times 2 is 10. So I can change both denominators to be a 10 by simply multiplying not only the denominator by 2, but the numerator by 2. 2 times 2 is 4, and 2 times 5 will give me 10. I can change 2 to become a 10 by multiplying both 2 by 5 as well as 1 by 5. So we're essentially multiplying this fraction by 5/5, which is just a very fancy 1. 1 times 5 is 5, and when I add, going straight across, I have a common denominator of 10, and 4 plus 5 is 9. So you should have ended up with 9/10 as your answer. For number 2, 3 and 9. Well, 3 can go into 9, so therefore 9 is our common denominator. So I'm going to change this. Let's change both of our fractions to have a common denominator of 9. 1/9 will not change at all, but the other one will. And in order for 3 to turn into a 9, I'm going to multiply 3 times 3. And whatever you do to the bottom, you have to do to the top. And that's multiplying 2/3 by a very fancy one of 3/3. 3 times 2 is 6. Now, by doing this, we're not changing the value of the fraction, we're just changing the look of it so we can actually work with the fractions to come up with an answer. And now that I have a common denominator of 9, I'm going to add the numerators, and I end up with 7/9. So 7/9 is my answer. For number 3, I'm subtracting these fractions, and I'm looking at the denominators. 11 can go into 22 evenly, so that means that 22 is our greatest common factor. So I'm going to change both of my denominators to be 22, and fortunately my second fraction will not change. It'll remain 4/22. Now 11 becomes a 22 by multiplying it by 2. And whatever you do to the denominator, you do to the numerator, and 2 times 10 is 20. So I'm going to subtract going straight across, and I end up with 16/22. Now I'm not finished because both 16 and 22 are both even numbers, so they both have a common factor of 2. So I'm going to simplify that even further by dividing out a 2. 16 divided by 2 is 8, and 22 divided by 2 is 11. So 8/11 is my answer. So you always have to keep your eyes peeled for opportunities for you to simplify your answers, simplify your fractions, because simplest form is what I'm going to be looking for. For number 4, this was probably the easiest one on the whole warm-up. We said the common denominator is already there, and we end up with, adding our numerators, we end up with 5/5, and 5/5 is 1. So our answer in this case is 1. Hopefully you did very well with this because we're going to be taking this concept to another level with today's lesson. So the procedure for adding and subtracting rational expressions is the exact same. So the procedure used to add or subtract two rational expressions depends upon whether the expressions have like or unlike denominators. So to get started with some easier problems, we're going to start with like denominators. So to add or subtract rational expressions with like denominators, we simply add or subtract their numerators. Then we place the result over the common denominator. So that's exactly what we're going to do. So we have our property of A over C plus B over C. Well, they both have in common both have a common denominator of C, so we simply add the numerators. The same thing goes with subtraction. So if we have a common denominator, we're going to simply subtract our numerators. So in this case, we have 5x squared as a common denominator, so we're going to add the numerators, and we end up with 3x plus 7 all over 5x squared. This is your answer. For this example, we have x plus 1 as our common denominator, so we subtract the numerators. And that is going to be 9x cubed minus x squared. And we could probably factor that even further by making that an x squared times 9x minus 1 all over x plus 1. And this is in factored form, and I would prefer that if you can factor either your numerator or denominator, please make sure that you do so. So now looking at example number 1, we have a common denominator of 12x, so we're going to combine our numerators. So 7 minus 2, that is 5. So our answer is 5 over 12x. There is nothing further for us to do. So we just simply subtract our numerators, and that is it. Before we go on to example number 2, I want to show you a second example. So we're going to call that example 1, and I'm going to call this example 1 letter A, and here's example 1 letter B. And for the reason why I want to show you this is because I don't want you guys to make a common error. So here's our example. We have 4x minus 7 all over x minus 2 minus 3x plus 3 all over x minus 2. Now we have a common denominator, and that denominator is x minus 2. So I'm going to subtract the numerators. So I'm going to write 4x minus 7, but I am subtracting not just 3x, but I'm subtracting the entire numerator of 3x plus 3. So that means I need to put this into parentheses and make this 3x plus 3 inside of the parentheses so I can distribute that negative to every single term. So this is going to become 4x minus 7 minus 3x minus 3 all over x minus 2. So we are subtracting every single part of that numerator in the second fraction. So I'm going to combine my like terms. 4x minus 3x is x, and negative 7 minus 3, that is negative 10. This is all over x minus 2, and this is simply our answer. Please do not eliminate the x's. Please do not divide negative 10 over negative 2. They are the main operation in both the numerator and the denominator is not multiplication, so there is nothing further for you to do in this case. That is a common error. Please do not fall for that trap. All right, let's go ahead and move on to example number 2. In example number 2, I'm going to call this example letter A as well. Both of these fractions have a common denominator, so we're going to add the numerators. So our common denominator is x squared plus 1, and my numerator is going to be 2x squared plus 2. Now, both 2x squared and 2 have in common a 2, so I'm going to factor out a 2, and my leftovers is x squared plus 1. This is going to be all over x squared plus 1. Now, this is an opportunity for you to eliminate because we have the exact same thing in the numerator as well as the denominator, and we have a main operation being multiplication. So the x squared plus 1s, they will cancel out, leaving us with the answer of just 2. So that is our answer. It is simply 2. Let's go ahead and look at a second problem. So the second problem, I'm going to have 2 over 3x squared plus 1 over 3x squared. So both of these fractions have a common denominator of 3x squared, so I'm going to combine the numerators. 2 plus 1 is 3. Now, in the denominator, the main operation is multiplication, so I can eliminate the 3 on the top as well as the bottom because technically the main operation in the numerator is also multiplication. Every single number by itself is being multiplied by 1. So the 3's will cancel out and our answer is going to be 1 over x squared. And that is our answer. So that's how you add and subtract fractions or rational expressions with common denominators. So now what I'm going to practice is how to come up with a common denominator whenever the denominators are not equivalent. So this next skill is how to find a least common multiple. Please note that a least common multiple is essentially the same as a least common denominator. We call that an LCD. So a least common denominator and a least common multiple, they go hand in hand. So let me give you some examples of least common denominators and least common multiples, and I'm going to put this information on the side right here. So let's say that you have a fraction that has a denominator of 3 and another one that has a denominator of 3. That means that your least common multiple is going to be 3. Or let's say that you have a denominator of x and the other one has a denominator of x. Your least common multiple or your least common denominator would be x. Or let's say that you have an x plus 2 and an x plus 2. Your least common multiple is going to be x plus 2. Let's say that you have a denominator of 3 and a denominator of 9. Your least common multiple is going to be 9. And that's because 3 can go into 9 evenly. And so that's going to be 9. Let's say that you have a least common multiple of 3 and 2. So you have 2 different denominators of 3 and 2. Your least common multiple is going to be the product of 3 and 2. Both 3 and 2 can go into 6. 3 and 2 can go into other numbers like 12 and 18 and 24, etc., etc. But we want the least number, the smallest number that both 3 and 2 can go into, since 3 is not a factor of 2 and vice versa. So in this case, it's going to be 6. Let's say that you have a denominator of x and x squared. Well, whatever the highest degree is, wins. X can turn into x squared very easily by simply multiplying x by another x. So x squared is going to be our least common multiple. Now just know that whatever the highest exponent is, that's the winner. So the highest exponent is your winner, and that's going to automatically be your least common multiple. Just like if I gave you x plus 2 and x plus 2 squared. Your winner is going to be the highest exponent, and that's going to be x plus 2 squared. Now, this concept might be very easy for you, and that is a wonderful thing. I want to strongly emphasize how to determine what a least common multiple is using very basic information. So now, what we have here is we want to find the least common multiple of 5x squared minus 45 and 4x squared plus 24x plus 36. So what we want to do in order for us to come up with the least common multiple is to pretend as if these two expressions are denominators. And I would strongly recommend factoring each of these polynomials completely, breaking it down as far as you possibly can. So looking at 5x squared minus 45, both of these terms have in common a 5. So my leftovers are going to be x squared minus 9. Now, x squared minus 9, that is a dots. So because it's a dots, I'm going to break it down even further into 5 times x plus 3 times x minus 3. Now I'm going to look at 4x squared plus 24x plus 36. All of these terms have in common a 4. So I'm going to factor out a 4. My leftovers is going to be x squared plus 6x plus 9. So this is equal to 4 times, well, x squared plus 6x plus 9 is something very special. It's a PST. It's a perfect square trinomial. And I can break that apart into an x plus 3 squared. So now if I want to identify what my least common multiple is, I'm going to write down each factor, everything that is separated using a multiplication sign, to the highest power that it occurs. So that means that anything with the highest exponent is automatically the winner. So I'm just going to identify the least common multiple by identifying every single piece, or picking apart every single piece of the factored polynomials. So what I mean by that is this. There is a 5. 5 is part of my least common multiple. There is an x plus 3 to the first power here, but in the other one, we have an x plus 3 to the second power. So x plus 3 to the second power wins. There is an x minus 3. There is no other x minus 3 as a part of the factors. So x minus 3 is part of my least common multiple. Then I have a 4. So this is going to be times 4. And if you want, you could probably break that down into 2 squared if you would like. But now I have addressed every single piece, and I'm going to simplify this. 5 times 4, that is 20. X plus 3 squared times x minus 3. That is my least common multiple. Now let's go ahead and practice this concept even further. So please note that you can always find a common denominator of 2 rational expressions by multiplying their denominators. However, your least common denominator is what our goal is. So which is the least common multiple of your denominators? So if you go with the LCD instead of simply multiplying the denominators together, you will prevent yourself from having to do a ton of simplifying at the very end. So that's all that this really means, is that by identifying your LCD instead of simply multiplying your denominators together, you're saving yourself a ton of work. That's all that this little phrase is saying. So for examples 3 and 4, what we want to do is we want to identify the least common multiple. So I'm going to take 5x cubed, and I'm going to break it down into its factors. So this is really 5x cubed is simply 5 times x cubed. And 10x squared minus 15x, well, both of these two terms have in common an x, and they both are divisible by 5. So this is really 5x times, my leftovers is going to be 2x minus 3. So now that I have both expressions factored, I can identify my least common multiple. My least common multiple, well, this one has a 5 to the first power and a 5 to the first power. So a 5 to the first power is the least common multiple. Up here we have an x to the third and an x to the first. So an x to the third wins. So an x to the third. And then we have 2x minus 3. So every single factor is represented, and here is our answer. 5x cubed times 2x minus 3. That is our least common multiple. That is it. There is nothing further for you to do for example 3. Let's go ahead and look at example number 4. I'm going to write down 8x minus 16, and both 8x and 16 have in common an 8. So I'm going to write that down as 8 times x minus 2. Now I'm going to look at 12x squared minus 12x minus 72. Oh, before I continue, 8 is something special. 8 is really 2 to the third power times x minus 2. If you know that you're working with a perfect square or a perfect cube or something to that effect, I strongly recommend rewriting it with a base that is prime or a base of something that is a little bit simpler. Just based on experience, and just giving you a heads up and keeping your eyes peeled for different factors. So the next one we have 12x squared plus 12x minus 72. So 12x squared minus 12x minus 72, they all have in common a 12. And my leftovers is going to be x squared plus x minus 6. So 12, I can break that down into 2 times 2 times 3, because 12 is really 4 times 3, and 4 is really 2 times 2. You can even write it as 2 squared if you would like, which I think that I might want to do that. If you don't, it's really not that big of a deal. You'll still get the right answer. And I'm going to break apart x squared plus x minus 6 into 2 parentheses. Splitting apart the x squared into an x and an x. And I'm going to ask myself what two numbers would multiply together equal negative 6, but together add to equal 1. And I believe that that's going to be a positive 3 and a negative 2. 3 minus 2 is 1, and I think that that does work. So now if I'm going to find my least common multiple, okay, so I have a 2 to the third and a 2 squared. So the one with the highest degree will win, so 2 to the third power wins. I have an x minus 2 and an x minus 2. Both are being raised to the first power, so just one x minus 2 will be included. So I've already talked about the 2's, I've already talked about the x minus 2's, so I don't need to talk about this 2 anymore. And now I have a times 3 and an x plus 3 left over. So now cleaning up our least common multiple, 2 to the third power is 8. 8 times 3 is 24. And then we have x minus 2 times x plus 3. And this represents our least common multiple. So now we're going to use the skill of identifying a least common multiple by adding and subtracting rational expressions with unlike denominators. So in order for us to add or subtract rational expressions with unlike denominators, we're going to find a common denominator. Then we're going to rewrite each rational expression using that common denominator, and then we're going to add or subtract. So here we go. Looking at example number 5, I have a denominator of 4x and a denominator of 7. So I need to come up with a common denominator. So looking at my least, I'm going to just write my aside work right here. I'm going to identify my least common denominator. My LCD or LCM, whatever you want to call it, is fine. My first one is 4x, and that is equal to 2 squared times x. And then we have 7, so that is going to equal to just plain 7. You don't have to write 7 times 1, it doesn't matter. So my least common denominator, that's going to be 2 squared, which is 4, times x times 7. Every single piece will be represented just once. And if I were to clean this up a little bit, 4 times 7 is 28. So 28x is my least common denominator. So that means I need to change 4x to become 28x, and I need to change 7 to be a 28x. Now, in order to change 4x to be a 28x, I need to multiply 4 times 7. And whatever you do to the denominator, you do to the numerator. And 7 times 3 is 21. Now, in order for a 7 to turn into a 28x, what you do is you're going to multiply 7 by 4x. And whatever you do to the bottom, we're going to do to the top. So 1 times 4x is 4x. And 7 times 4x is 28x. Now that we have a common denominator, we're going to combine our numerators. So this is equal to 21 minus 4x all over 28x. There is nothing further for you to do. Please do not eliminate the 4 and the 28. The main operation in both the numerator and the denominator is not multiplication. All of these terms do not have something in common. Therefore, do not simplify, do not eliminate and say, oh, there's an x on the top and the bottom. Do not eliminate. Please do not fall for that trap. Please. All right, let's go ahead and look at example number 6. So example number 6, we're going to identify our least common denominator. And my first denominator is 3x squared. And if I were to break that apart, that would be 3 times an x squared. And my second denominator is 9x squared minus 12x. And both of these two terms have in common a 3 as well as an x. So that's going to be 3x times x minus 4. I'm sorry, that's 3x minus 4, excuse me. All right, so that's 3x minus 4. So picking apart all my pieces, I have a 3 and a 3, so 3 is certainly going to be part of my least common denominator. I have an x squared and an x. The x squared wins. It has the highest degree. And I have a 3x minus 4. So to clean it up a little bit, this is 3x squared times 3x minus 4. That is my least common denominator. So I recommend rewriting the 9x squared minus 12x in its factored form. That'll give you an idea of what you really need to multiply the top and the bottom of this fraction by in order to change it into a 3x squared times 3x minus 4. So I'm going to write 3x squared times 3x minus 4 plus 3x squared times 3x minus 4. That is my common denominator. And in order to change 3x squared to be a 3x squared times 3x minus 4, I need to multiply the top and the bottom by 3x minus 4. And I'm going to put 3x minus 4 into parentheses. 1 times 3x minus 4 is simply 3x minus 4. Now I'm going to ask myself, what do I need to multiply 3x times 3x minus 4 by to turn it into 3x squared times 3x minus 4? And it looks like the only difference is the x turns into an x squared. So that just means I'm going to multiply the top and the bottom by x. So I'm going to multiply by x over x. And x times x is x squared. So now that I have a common denominator, I'm going to combine my numerators. And I notice that I have an x squared here, so I'm going to make that my leading term. So I have x squared plus 3x minus 4. This is all over 3x squared times 3x minus 4. Now, final answers need to be written in factored form, so I'm going to try to factor my numerator if I can. Sometimes you can, sometimes you can't. Just be prepared for that. So I'm going to try to split apart the x squared into an x and an x, and I'm going to see if there's any numbers when multiplied together that equal -4, but together add to equal 3. And I do believe that +4 and -1 will work. 4 minus 1 is 3. And 4 times -1 is -4, so it does work. And we have x plus 4 times x minus 1 all over 3x squared times 3x minus 4. None of the parentheses are the same, but at least it's in factored form, and this represents our answer. All right, let's go ahead and flip the next page to the next page. We have 2 more examples, and then we are finished. I would like you guys to please go ahead and try example 7 and example 8 on your own. So go ahead and try example 7 and example 8 on your own just to see how you do. I'm going to stop talking for a little bit, give you some time. Please go ahead and pause the video, and we'll go from there. All right, let's go ahead and see how well you did. So we first need to identify our least common multiple or least common denominator. Let me change that to a D. Oh, excuse me. right, we have a 10x squared. I can break that apart into 2 times 5 times x squared. And we have 5x squared minus 10x, and that is equivalent to 5x times x minus 2. So my least common denominator, if I were to identify each piece that we need, is going to have a 2, a 5, x squared wins, and an x minus 2. And to clean that up a little bit, that is 10x squared times x minus 2. So I need to change my denominators to be a 10x squared I wrote it down too far. So I'm going to make this a 10x squared times an x minus 2 plus 10x squared times x minus 2. And I'm going to change 5x squared minus 10x to be 5x times x minus 2. All right, so in order for 10x squared to turn into 10x squared times x minus 2, I'm going to multiply the top and the bottom by what it needs, which is x minus 2. So that's going to be x minus 2 over x minus 2, and I'm going to distribute that 3 to each term. 3 times x, that is going to be 3x, and then minus 6. Over here, I have 5x times x minus 2 needs to turn into 10x squared, so that means I need to multiply the top and the bottom by 2x. And 2x times 2x is 4x squared. So now that I have a common denominator, I'm going to combine my numerators, and I have a 4x squared, so that's going to go in front. So we have 4x squared plus 3x minus 6. This is all over 10x squared times x minus 2. And what I'm going to do now is I'm going to try to see if I can factor that numerator into 2 parentheses. So I'm going to try 2x and 2x first, because 4x could be 2x and 2x or 4x and 1x. So let's see what we can come up with. The factors of 6 are 3 and 2 and 1 and 6. So if I were to put 3 here and 2 here, that's not going to work because that's 6 and 4 does not give me a 3, so that's not going to work. And I can't flip around the 3 and the 2 because I'll have the same exact situation. So I'm going to try 1 and 6. And 2 times 6 is 12, and 12 and 2, that's not going to get me a 3 in any way, shape, or form. So I know that essentially 2x is out. So now I'm going to try the 4x and x. I'm going to put 3 right here and 2 right here just to see. 4 times 2 is 8. 8 and 3, that'll give me an 11, or that'll give me a 5, and that doesn't help me at all. So let me try to flip around the 2 and the 3. 4 times 3 is 12. 12 and 2, that's 14 or 10, so that's not going to help. So I can try 1 and 6. Let me try that. 4 times 6 is 24. Nope, that's too big. All right, let me flip around the 6 and the 1. 4 times 1 is 4. 6 times 1 is 6, but my goal is to get a 3, and that'll get me like a 10 or a 1. So what this tells me is that 4x squared plus 3x minus 6 is not factorable. This is simply my answer. 4x squared plus 3x minus 6 all over 10x squared times x minus 2. So let's go ahead and look at example number 8. So for example number 8, we first need to identify our least common denominator. And for your least common denominator, we have 3x minus 15. Both of these terms have in common a 3, and the leftovers is x minus 5. Then we have x squared minus 4x minus 5. And I'm going to try to break that apart into 2 parentheses. Splitting apart the x squared into an x and an x, I'm going to ask myself what 2 numbers multiply together to equal negative 5, but together add to equal negative 4. And I believe that's a negative 5 and a positive 1. So now I'm going to identify my least common denominator. but putting 3 out in front. Both have in common an x minus 5, and the x minus 5 is being raised to the first power, so x minus 5 to the first power is part of our least common denominator, then x plus 1. So now I'm going to rewrite the factored form of each denominator just below the denominator. So this is going to be 3 times x minus 5. And over here I have an x minus 5 times an x plus 1. And I know that my common denominator is supposed to be 3 times x minus 5 times x plus 1 minus, I have 3 times x minus 5 times x plus 1. All right, so I want my denominator to be the same, and it looks like I already have a 3 and an x minus 5, but I need an x plus 1. So that's what I'm going to multiply the top and the bottom by, is x plus 1 over x plus 1. And I'm going to distribute the x to each term, making that x squared plus x. And then for my other piece, I'm going to zoom in just a little bit, just so that we're all on the same page and you can see everything. This denominator already has an x minus 5 and an x plus 1, but it needs a 3. So that's what I'm going to multiply the top and the bottom by, 3 over 3. And I'm going to put 2x plus 2 into parentheses and distribute that 3 to every single term. 2x times 3, that's going to be 6x, and 2 times 3, that's going to be plus 6. Now be careful, we are subtracting here, so that means we're going to be subtracting every single piece of the second numerator. So you can skip a step if you would like by just knowing that you're going to distribute the negative to every single term, or you can write it out using parentheses. It's your choice. I'm going to try to do a shortcut because this problem is already long and the lesson has already been pretty long so far. So I'm going to write this as x squared plus x minus 6x minus 6. I'm going to combine my like terms, and we have x squared minus 5x minus 6 all over 3 times x minus 5 times x plus 1. So now I'm going to try to see if I can factor x squared minus 5x minus 6 into 2 parentheses. I'm going to split apart the x squared into an x and an x and see if there's any factors that when multiplied together equal negative 6, but together add to equal negative 5. And I believe that 6 minus 1 is 5, so I'm going to make this negative 6 and a positive 1. And negative 6, so that's 1 minus 6, that's negative 5, so it works, cool. So this is all over 3 times x minus 5 times x plus 1. Holy smokes, we have the same thing, the same parentheses on the top as well as on the bottom, so that's going to eliminate, leaving me with the answer of x minus 6 all over 3 times x minus 5. That is our answer in this case. That is the end of today's lesson. I know that this lesson was a lot. Please feel free to email me if you have any questions over anything. Also, if you need to go back and rewind and listen to the lesson again, maybe try some of the problems again as your turn, that's not a problem as well. We will certainly talk about this the next time I see you in class. I hope you have a wonderful day, and until next time.